Here we're looking at formula and functions. In this question, we're going to try to rearrange this formula so that V is the subject. That means that V is going to be on its own, either on the left or the right-hand side. It's not going to be multiplied by anything. It's not going to be square rooted or squared. It's not going to be negative. It's just going to be V equals something or something equals V. Lots of ways to approach it. The most simple way to do it is to think about if you had the V, what operations would you do first, thinking about BIDMAS, and then as you're rearranging it, do the opposite. So for example, if we knew that V was 10, in this one we do 10 squared first because of indices coming first in BIDMAS, then we multiply it by m, and then we multiply it by a half. So we want to do the reverse of those operations if we want the easiest possible way to rearrange it. So in that case, I'm not going to start by square rooting everything. If you do that, you end up with something that looks like this. You get square root of E on that side, but you've got to square root everything on this side. You can't just choose to square root the V. You're doing the operation to both sides of the formula or the equation, so therefore the whole thing needs to be square rooted. Now you can actually do it from here. I'll show you in a minute after I've done the easier version what would happen if you did this, and it is possible. It's just not the simplest way to do it. So let's just scrap that for a second and instead start off by multiplying by 2, because that's the last thing you would do if you were working it out properly. You'd divide by 2. So that's going to give us this, and then try and get rid of this m, so we're going to divide by m. And now we'll square root it, because we've just got a V there. So everything there gets a square root, and you get that as the answer. Just for interest, let's have a look at what happens if we do start by square rooting. So we'd get square root of E, and then as I showed before, square root of everything on that side. Well, going back to the way surds work, you can break this up into separate square roots. So we'll leave that E square root on its own for now, but that means we can actually break up this into a half m, and then as a separate square root, the V squared. Well, that's quite good because you can do the square root of V squared, and this is going to be V. So actually it's worked out okay. If we divide this square root off now, we're going to get square root of E over square root of half m equals V. Now actually we've got V on its own here, so that would be an acceptable answer. It's just not fully simplified yet, and you might be thinking, well, how does that equal that? Well, again, from surds, if you're dividing two square roots, that can become a single surd division. So if I just do that over here, that is going to become E over half m. And here we've got E divided by a half. Well, dividing by a half is the same as multiplying by 2. So these two expressions are actually equivalent. So it does work both ways. You just have to be careful to do it properly. Whenever you do something, do it to the entire side, not just the one little thing you were trying to target. Let's look at another example of rearranging formula. So in this case, we've got 5xy plus 2 equals w plus 3xy. I'm trying to make y the subject here. Well, we've got y in two places. So initially, we don't want that. We're going to try and get all the terms with y on the same side. So I'm going to subtract 3xy from both sides. You've got to do 3xy. You can't just take the y away because that is a single term. 3xy is a collection of terms that can't be broken apart unless you start dividing by 3 or dividing by x. But if you do divide by 3 or divide by x, you've got to divide every single thing by those. You'd end up with that divided by x, that divided by x, that divided by x, which makes it more complicated. So if I subtract 3xy from both sides, you get this. 5xy subtract 3xy, well, they're both xy terms, so that just means we're left with 2xy's plus 2 equals w. Trying to get the y on its own, so again, thinking about BIDMAS, I'm not going to try and divide off this x right now, because the last thing that would happen with BIDMAS is you'd add this 2. So that's the first thing we're going to try and get rid of. It's also, the 2 is further away from the y, it's easier to move away, you can see that visually. So if we subtract the 2, we get 2xy equals w subtract 2. Now I'm going to divide off this 2x here. Remember, when I do that, I don't just divide the w or just the 2, I divide everything. So I get this big line here, and that's your answer. You can actually see there. So I divided everything here by 2x. Most challenging type of problem for rearranging is this. So here we've got x in 2 places again, but in this case we're going to have to do an extra step to collect the x's into 1. So we're trying to make x the subject. So we've also got a fraction here which we don't really want. Fractions are usually things to try and get rid of if you can. So we've got everything here being divided by x. So an obvious way to start is to multiply everything by x. So you get vx over here, and then you get 1 plus 7x there. We've got x in 2 places. We don't really want that. I'm going to try and collect all the x's onto the same side. So I'm going to subtract 7x from both sides. So I get vx subtract 7x equals 1. X in 2 places, we can factorize this now, put it into brackets, and that's going to take our 2x's into 1. There's a technique you'll see quite a lot. Whenever you have a letter in 2 places, factorizing is usually the way you're going to get that letter from 2 places into 1. So the x is the common factor, so that's going to go on the outside. On the inside is going to be v subtract 7, and that still equals 1. We want the x on its own. Remember, this bracket means x multiplied by the bracket, so to get rid of it, we're going to divide it off, and that's going to leave us with this. You can choose to write the bracket around this or not. There's a bracket here that has to be, because it's the entire thing times x. This line here implies a bracket, so you can do that if you want, but the bracket is implied by that line being there. So that's your answer. You get a slightly different answer if you decide to take the vx here and subtract it and put it over here, and then you have your minus 1 there. It will be an equivalent answer, but this is a more sensible way of doing it, I think. So we have also now functions. So functions are usually written like this. This just means that x is the input and that some process happens to x and it gives us an output. So in this particular case, our function is 5x squared. So we take the x, we square it, we times 5, and that gives us our output. So if I want to put x as 2, so that's my input now, I'd write this, the x becomes 2, that means in this process here, the x is now 2, so I'm doing this process. Remember BIDMAS again, you must do the squaring first, so it's 2 squared is 4, times 5 is 20. Common wrong answer in this question would be to do 5 times 2, which is 10, and then try and square that to get 100, but that's not right. You've got to do the squaring first because of BIDMAS, then the multiplication. So the right answer there would be 20. Let's just take another quick example from this one. Let's say we're doing something like f negative 3. So in this case, we would do 5 multiplied by negative 3 squared. Again, similar problem. Negative 3 squared is positive 9. The calculator will tell you that's wrong. If you're going to do it on the calculator, you must put it in a bracket and then square it. Otherwise, just use your knowledge of negative numbers to know, well, that's going to be 9 times 5, positive 45. So we have another function here, which is g of x. You can use any letter for functions, it doesn't have to be f. So g of x is another function. This function is 2x plus 1. So you take your number, you times 2, you plus 1. So if I put in 10, you go 10 times 2 plus 1, it'd be 21. But I'm going to use this to show something else you can do with functions. You can actually take that gx term and you can do algebraic things to it. So you could do something like 3gx, which would mean taking whatever that is and multiplying it by 3. Well, that's what gx is, 2x plus 1. So that means you would be doing this. And that's something you can simplify. If you expand the bracket, you're going to get 6x plus 3. You can also do things like, instead of putting x in there, put something else in there. So it'd be pretty obvious. If I put a y in there, that would become 2y plus 1. If we put a 10 in there, as I said, it'd be 2 times 10 plus 1. But you could put another algebraic expression in there. So let's say I put in x plus 2 in there. I'm still doing the same function. I'm still doing this, but I'm doing it to this instead of just to x. So the function is take your input times 2 plus 1. Well, this is my input now. So I get this. It's exactly the same thing, 2 of this plus 1, and this happens to be x plus 2 now rather than just x. And again, you could simplify that and you get this, expand the bracket, and that would be 2x plus 5. So sticking with those same two functions, I've written them out the top there. You can do something called a composite function, which is you do one function, then you do the other function. Can be confusing initially. If you have g f of x, that means you do f first, then you do g. It's written that way because the x is the input, it's going to hit the f first, then it's going to hit the g. So if we do the f first, when we put x into the f function, we get 5x squared. That means that's what's going to go into g. So the next step I'd write out is the g still has to be done, but because we've done the f, what's going into g is actually this now, and that's come from the f. So we're now doing this of the g function. Remember, it's 2x plus 1, so that means we're going to do 2 times 5x squared plus 1. So we've just replaced the x here with whatever we're inputting, and then we can simplify that. Well, I've put in a bracket here just to show what the input was, but all that's going to happen here is we're going to do 2 times 5, 10x squared plus 1. That 2 is not timesing the 1, remember the 2 is just timesing the x, and the x in this case was this term here. Other way around, we would do the g first and then the f. So if we do the g, we get 2x plus 1. So that means the f is going to receive a 2x plus 1. And the f function is 5x squared. This one's a bit more complicated. It means we're going to end up with 5, and then the x has become this 2x plus 1, and that's getting squared. That means we're going to simplify this, expand a double bracket. So we'll go over here to do that. Put 5 on the outside, and I always prefer to write out the full double bracket expansion like this. So the 5 is going to sit there for a moment. Let's expand the brackets. Do that. We're going to get, let's put this 5 here. We're going to do 4x squared. That's going to be 2x plus another 2x, so we're going to get 4x in the middle, and then plus 1. So that whole thing there in the bracket is what happens when you expand these double brackets, but 5 was being multiplied on the outside, so then everything's going to get times by 5. 20x squared plus 20x plus 5. That's composite functions. The last thing you can do with functions is invert them. So we'll stick with the same two functions again. When we're inverting, we use this -1 power notation. That just means the reverse of something. So in this case, if we're doing 5x squared as our normal function, what's the reverse of that? Sometimes you can just work it out. If it's x squared multiplied by 5, you can just reverse that in your head and you can probably get the right expression where it's going to be divide 5 and then square root. But a better way of doing it is to rewrite the original function using y equals x squared. This y doesn't really mean anything. It's just a placeholder that's going to allow us to do some algebraic rearrangement, and it will disappear at the end once we've used it. So we're going to replace the y with the x. We're going to switch the input and the output around. So the x is going to be the subject and the y is going to be the thing where stuff is happening to it. So we're going to divide by 5, and that'll get us that, and then we'll square root both sides, and that's that. So that's the inverted function. That's dividing by 5 and square rooting it, which we kind of saw just by thinking about it earlier. But we write this, actually I'll do it under here, we write this as f of x minus 1, and this is our function expression, but we're going to use x to write. Remember, the y was just there as a placeholder that we use to do the rearrangement and find the rearranged formula, but we don't actually want to use y, we're going to use x for our function. So we write this. So it becomes square root of x over 5. Do the g1 as well, same method. Write it as y equals 2x plus 1. Again, you can probably just work out in your head what it's going to be. What's the reverse of times 2 plus 1? Well, you can probably guess it, but let's see if it's right. Rearrange this then, so y minus 1 equals 2x. Y minus 1 over 2 equals x. And then we're going to put this into the function notation properly. So that's going to be g in this case minus 1 of x is equal to x minus 1 divided by 2. So that's how you work with functions and formula. Try the questions.